Thank you, Mario, for the introduction. So good afternoon, everyone. Hope you had a good break and had some tea, coffee before the talk. So let me start with the talk now. So my topic is, so you want to run containers, but which OS do you want to run it on? So this is, we have seen an uptick in the number of people using the whole container ecosystem with Kubernetes, Docker in the picture. And there has been a strong focus on the OS side as well on to make things better for this whole ecosystem and support the ecosystem of containers. So moving on. So the agenda of the talk is, so I'll be having a 25-minute talk, and I'll be giving my intro at the beginning, and then we will discuss on why we need a container OS, why there is a need for container-focused OS. Then moving on, so if you have read my CFP, there I submitted that this container OS focuses on 4 pillars, which are minimalism, speed, security, and immutability. Now, once I cover all these 4 items, and then I'll give you a brief introduction on a few of the existing container OSs out there. And after that, on how you can take how you can use this talk as a leveraging point to decide which OS you would like to pick up for your next container workload. And then finally, I'll give a brief introduction of Flatcar Container Linux. That's a project I work on a day-to-day life. I've been associated with it for 4 years now, and I'll definitely love to give a brief introduction about it so that you can use it for your next workload. And finally, a few rounds of questions. I would love to hear what your thoughts, any feedback, or any questions you have for the talk. Cool. So moving on. Hi, I'm Sayan Chowdhury. I am from India. I work for Microsoft, and I'm based out of Bangalore in India, and have been working for the Flatcar team for the past 4 years now. So just to give a small history, so Flatcar was initially spawned in this company called Kinfolk, which was later acquired by Microsoft in 2021. And that's how we ended up being at Microsoft and building this amazing OS with more better support from the company. And we are essentially under the Azure umbrella. And we try to, even if you have any questions about Azure, you'd feel free to contact me after this talk. So the 4 pillars. So what is a container focused OS? So we essentially have the focus areas, if you see, are targeted for 4 pillars, which is minimalism. It focuses on how minimal we can keep it. Then the next is speeds, security, and immutability. And I'll go through them one by one. But before that, why do we even need a container OS? Now, the thing is, like, if you have worked in the DevOps space, then in the recent times, you have seen that the space is widely divided into 2 categories. One is the mutable infrastructure, and the other is the immutable infrastructure. Now, what is a mutable infrastructure? So the mutable infrastructure means that you have your setup, you have your servers. If there are things that are going wrong, you basically, what you can do is that you SSH it into the server and then quickly edit things or update your configs or restart machines or have a touch with the servers wherever and whenever you need. Whereas in an immutable infrastructure, the idea here is that you try to break, and if things break, you try to you basically try to kill that particular server and spawn it up again, and it should be in the same state as the previous one. So in case suppose your OS breaks, so what you can do is that you can maybe update the base image and then spawn up a new instance immediately with the updated configs. Now, why do we need this? The reason is with the is in my next slide, which is cattle not pets. So this has been a very a term that has been going on for ages now in the container ecosystem, where we treat our the basic, just to give an example or to understand this in a much finer details, is that when you have a pet, you take care of it, you give a more you have a name for your pet, you take, if there is some illness to the pet, you take care of it, take it to the vet and take care of it, love it, give it some care. Whereas in terms of cattle, you have, if you have seen a cattle farm, they are particularly numbered, maybe they are by category by breed, or and they are doing just the job they have to do. So if this is taken into the perspective of infrastructure, so pets are basically servers which may be contained in a mutable infrastructure, whereas in cattle you have your servers grouped by their categories. Suppose you have a database cluster, or your web cluster, or your backend cluster, and then whenever there is some issue, you don't really cater to their needs. If there's something wrong, you just kill that particular machine and spawn a new machine up. So that's the ideology that has been going in the microservices space with the container ecosystem, that if just so that we can have faster deployments, you have much more reliability, and it's easier to debug issues in case things go wrong. And yeah, so this is where the container OSes comes into picture, because it aids you to build up a system that can support the life cycle that you have for your apps. Now, now going into what is a container focused OS. So the first topic is minimalism. So with the minimalism part, we are seeing here three primary aspects. One is a minimal package set. The second is minimal human interaction, and third is minimal resources. So what we are targeting here is with the OS that you have. So essentially, suppose there is a container OS. Most of the container OSs don't have a package manager inside them. So you are limited to the packages that are provided by the OS that you're using, and they are usually small, as in you have only the minimal packages that are required inside of the OS, and that can, depending on what are the OS goals, which OS are you using, that can be from few OS have lesser than the required, few have more, but it all depends on the goal that the OS has. But all of them would have a very small set of packages which is required for the containers to run. The next is minimal human interaction. So as I mentioned, like we try to build a cater to build a immutable infrastructure where you as a person would not require to SSH into the machine. There are a few OSs which actually restrict to do so, and others have the option to SSH, but then at the end of the day, we want you to tear down machines and if required, spin up a new machine with updated versions or updated packages, or if your apps are getting upgraded, you tear down the machine and build up a new one. And then finally, minimal resources. With lesser number of packages, you end up having lesser resources being used, and more of the resources can be used by the apps that you are working with. The next is speed. So with speed, we have faster deployments. Then you have optimized for container workloads and boot speed. So given you are essentially tearing down, so whenever the boot speed, whenever you're booting up a new machine, it would be ready in a few minutes, or actually seconds, so to speak. Now, this is because there is a less overhead, there's a less dependency chain involved during the boot process. So you would see a tangible reduction in your deployments. They would be accessible or be available in a lesser span of time. And then because this is our focus is only for containers, so you would see that most of them are very highly optimized for all your container workloads. Be it like all the tuning has been done for Docker or Podman, whichever container runtime you're using, or if you're using an engine like Kubernetes, it would be definitely be very highly paired up and in tuned with the Kubernetes releases, so that you get a much better performance at the end of the day. The next is security. Now, among all these 4 points, one of the biggest point that every OS puts a focus on is security, because given the number of CVs are getting released on a daily manner, the security leaks that are being happening around the world, security takes a very high center stage, and you will see this has a lot of points in it. So one factor comes is immutability. That's something I'll discuss at the end. But then the next is automatic updates. For example, every OS has a different implementation. Some do AB updates, some do some other kind of update mechanism, but all of the OS have the option that whenever there is a new release by upstream, they would end up giving a signal, or the payload is directly uploaded, and then all the OS that all the machines that on a particular version would be automatically updated, so that you have the highest or the latest patch versions on your infrastructure for the machines. The next point is reducing the attack surface. This essentially happens because when you have a lesser number of packages in your OS, essentially we have a lesser attack surface. The reason is there are lesser packages that would have faulty areas, and also because this is immutable, we see a sharper drop in the number of CVs that we need to attend to. Now, this is one of the target areas for most of the container OSs, that they keep this small so that your infrastructure is usually more secure than the normal traditional OSs, like suppose Ubuntu, Fedora, or others. Now, one thing I noticed while building this talk was that I actually gave a similar talk in 2019, the last FOSSASIA I came to, and it was for desktop. Now I saw that the points which I mentioned was these three last points were kind of the same thing I mentioned in my previous talk, because if you categorize container OSs, they can be broadly divided. I'm talking about infrastructure here, but it can be broadly divided into desktop as well. There are a few desktop container OSs as well, which you can use your day-to-day laptop on that. And finally, then you have the secure container runtime, as I mentioned, with the in-tuning happening for the various container runtimes. We try to have the latest container runtimes in all our with the container OSs. And finally, the principal least privilege maintaining, so that whichever services or users, whichever access that is required, they only have that access or ACS. And finally is immutability. So in immutability, as I mentioned, there is no individual package management. We highly focus that you run your container workloads. Anything you need is driven through a container backend, and then but you cannot really install anything on any of this container OSs. A lot of them have their root file system read-only, or for us, like it's a USR that is read-only, so that you can really not alter anything inside the root file system, which again increases the security of the OS overall. And then during the updates, whenever there is a new update, it automatically updates. But what if there is an issue? Suppose something broke down in between. So what do you do in that case? So most of the OSs have atomic rollbacks and updates. So it tries to update the OS, and if there is a failure mode, it is done by a different. All the OSs approach it in different manners, but at the end of the day, the result is that if something fails, it would re-roll back to the previous version, the stable version, and then you would not even see a thing. Suppose there is an update on a Friday evening, you would, if there's a breakage, you would even see a thing, and it would update to either the next stable version, or if something fails, it would re-roll back to the previous one. Single version identifier. Now, so for example, in Flatcar, so we really don't have multiple version. At any given point of time, it will be only one version that is getting attested. So we have an epoch time for when CoreOS started their first release, which was July 1st, 2013. Since then, we have been doing various releases. So each of them have like a single version identifier. So each OS would just pinpoint to one version. And then with the immutability, one great factor is it again reduces a lot of attacks. Like we in 2019 we had a runC vulnerability which was totally not affecting the container OSs because the way how it operates, and immutability was one big factor there. Now coming down to the OSs that are there in the market. So as I mentioned, we have Flatcar, which I'm part of. You have Talos, we have Fedora CoreOS, we have MicroOS, we have Bottlerocket, and we have Photon. Now these are the few container OSs that are out there, and people use it on a daily manner. But they are architecturally very different, though they imply all the fundamentals that I discussed now, the minimalism, security, speed, but how they implement is different. So just to give you an example, so Flatcar has this release policy of maintaining 3 channels, which is alpha, beta, stable, whereas Fedora CoreOS does it via streams, which is a testing stream, and then they have a production stream. Or for example, suppose you have the provisioning can be, so Flatcar, Fedora CoreOS, these all use provisioning agent called, like there's a software called Ignition. So we use that, but some other OS would use a different mechanism. Then for Flatcar, you would need to, you have the, like the USR is locked down, but then for others, you would have the root side system locked down as well. And then there are a few OSs which have SSH also blocked, so you cannot really SSH in. Like for example, Talos here is very interesting because you have an API to manage your workloads as well here. Now, how to choose? So what I would suggest is that in case if you're choosing a new container ecosystem, in that scenario, first thing you should look into is the configurability. So how you configure your system. So suppose the thing that I mentioned is, suppose you need to update your, so suppose you use cloud inits, or suppose as Ignition. So you are limited by the options that you have, but they are usually like Fedora CoreOS and Flatcar uses Ignition, and we contribute to Ignition together to make it better. So in that scenario, you would need to change on how you provision your machine or how you attend to your configuration so that you choose a good OS. Then comes the security, on how locked down you want your system to be or how free you want your system to be. That becomes a challenging aspect as well. So you basically pick up you do probably your analysis on your current setup and see which how much of a security need is for you. If you want your to SSH totally locked down, then probably you would choose from one of these OSs. Not sure what happened here, but yeah, so you could probably choose from one of these OSs, and then finally is immutability. Immutability is probably same for all of them, but that becomes a factor because if you need to update things, like for Flatcar, when you do Ignition, it's just on the first boot that runs and applies a config. But if there are other OSs which gives you option to append things later, then that could be also be added to your choice. Okay, so yeah, so as I mentioned, as I work with the Flatcar Container Linux team, so I wanted to give a small introduction about Flatcar Container Linux. So it's an OS that was spawned out of, it was forked out of by Kinfolk, forked out of Container Linux, which was maintained by CoreOS, and then we after it been AUL, we have implemented a lot of features in there. We actually quite went side stream, and the way we see things or the kind of the architecture what Container Linux has been totally changed to what Flatcar has. Like we are working on to build system extension and other features as well. Then you have the releases, which happens at a monthly cadence right now, but if required, if there are security patches, we increase the cadence to bi-weekly sometimes, but we have technically alpha, beta, and stable. Alpha is probably released every few weeks, and then beta at a more bigger cadence. We try to soak things, and then finally stable. Stables are one of the ones which has a lot of features going at once. And then we maintain a 18-month cycle for LTS. We release every year, but the support cycle stays there for 18 months. So yeah, and this was a requirement because with LTS, you try to find some stability there. So this also becomes a choice. Like if you want more stability, so LTS, Flatcar LTS becomes a good choice for you. And next is provisioning. So the provisioning for Flatcar happens through Ignition, and it's a first-time boot only thing. So you have Butane and Ignition working in parallel. So you can have configs, which actually helps you. It's a provisioning agent, so you can really set up your system and then reuse it again and again to have the same system at the end of the day. And then on the immutability and security aspect, so we tend to like our security cadence is we give a very high focus to security. So we try to have a very high cadence for any of the security fixes that are or the CVs are released, and we try to do a release whenever there is very high maintenance security that needs to be taken care of. And the last one is, it's got messed up, but the availability on the cloud providers. So we have a lot of cloud providers that we support, and we keep on adding more and more cloud providers every day. You could see Flatcar on DigitalOcean. So we have a server where we host all of our images if they're not on Marketplace. So you can take those images and upload them to the cloud providers. But if they're on Marketplace, we are there on like the Azure Marketplace. We are there on GCP. We are there on AWS and more that we have been working on. We recently, like, I guess we added the Bright Box. And the other thing is, the last thing I would talk is about the community, because it's an open source project, and it's growing day by day. We have, if you're looking to contribute, so we have open office hours every month, and it's on the 2nd of Wednesday, and a developer sync meeting that happens so that you can directly interact with your developers. With the developers on the team, and these are to cater to any of the needs that the community is having. And if you're looking to contribute, we are available on Matrix, where you can directly talk with us. So just to give an a list of the things that we have. So the flatcar.org releases shows all the releases. You can just go to flatcar.org, which would have all the information for you, and the GitHub repo is flatcar/flatcar. Documentation is there on Flatcar docs, and we actually built a tutorial because the whole container OS concept is pretty new. So we built a tutorial around it, which is a 4-step process, and you could read it through and follow it on your local machine, which is Flatcar tutorials. And then finally, our communication channels are, we do office hours or our Flatcar Jitsi server. So every month on 2nd Wednesday we meet. You could find it on GitHub discussions, and then we are there on the Flatcar Matrix. If you have any issues, you can directly drop on that channel. We are also there on Kubernetes Slacks, is Pound Flatcar. And if you have any questions related to Flatcar, you can directly jump in there. So now time for questions. We have time for questions? Or